Newton's laws of motion. Newton's first law, law of inertia. Newton's second law, F is equal to ma. And Newton's third law, action-reaction, by Jocelyn Callejas. Newton's law of motion. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. This tendency to resist changes in the state of motion is inertia. What this means is that an object will stay put. It will not move at all, and it will stay in that place forever unless an external force is applied to that object. If an external force is applied, the object will be able to move. This law of motion is inertia. Newton's first law of motion, which is law of inertia. An object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced outside force. Motion leads to motion and rest leads to rest. This is showing and indicating that no matter what, if an object is at rest, it must stay at rest. And if an object in motion is in motion, it must stay in motion and will stay in motion at a constant velocity unless it is acted upon by an unbalanced outside force, which is when a force applied in one direction is greater than a force applied on the opposite direction, creating an unbalanced force. In conclusion, when an object is in motion, it will stay in motion, and when an object is at rest, it must stay resting. Now that I have explained this, you might still wonder, what does this all mean? What does this all mean in Newton's first law of motion? Well, basically, an object will keep doing what it was doing unless acted on by an unbalanced force. If the object was sitting still, it will remain stationary. If it was moving at a constant velocity, it will keep moving. It takes force to change the motion of an object. Newton's first law of motion, law of inertia. In this slide, I'll be explaining more on inertia. Inertia is a tendency of an object to resist changes in its velocity, whether in motion or motionless. In short terms, objects tend to do what they are already doing. For example, if there are no external forces like gravity or friction, a thrown ball will continue moving in a straight line at a constant rate for eternity. Here on the picture listed to the right, you can see a pile of cherries. These pile of cherries will remain at rest unless acted upon by an unbalanced force, meaning that if there is no unbalanced force hitting the cherries, they must stay at rest for eternity. Another fact about inertia is that anything with more mass will have more inertia. An example would be, an elephant has more inertia than a mouse because it has more mass. Here is another example of Newton's first law. A ball is rolling down a hill and it will continue to roll unless friction or another force stops it. Another simple example is the picture listed on the left. A simple example of Newton's first law is shown on the picture to the left. The ball is at rest and it will remain at rest unless a net force is acted upon it. The ball under that one is a ball in motion, and the ball will stay in motion at a constant velocity unless some net force is acted upon it as well. Here are some more simple examples of Newton's first law of motion. In the first picture on the right, you can see that the Earth is being rolled by the moon. The moon will keep revolving around the Earth forever unless it is acted by an unbalanced force. This is shown in the picture. Another easy example is shown on the picture below that one. Unless acted upon by an unbalanced force, the golf ball picture would sit on the tee forever. Before we move on, here is one last example of Newton's first law, except with a real-life example. Here's a picture listed on the right. Don't let this be you by wearing your seatbelt. Because of inertia, objects, including you, resist change in their motion. When the car going 60 miles per hour is stopped by a trash can, your body keeps moving at 60 miles per hour. Meaning, If your car is going at a constant fast velocity, even if that velocity is stopped with the car, anything inside of that car, including you, will keep going at that speed. This is how car accidents are caused. Avoid this happening to you by wearing your seatbelt so you are pushed back. Newton's second law of motion. The net force of an object is equal to the product of its mass and acceleration. This can be shown with the equation F is equal to m times a, which is mass times acceleration. When mass is in kilograms and acceleration is in miles per second squared, the unit of force is in newtons. 1 newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter per second squared. An example here of Newton's second law of motion would be, here's an example question. How much force is needed to accelerate a 1,400 kilogram car 2 meters per second squared? As you can see here, the mass is equal to 1,400 and the acceleration is equal to 2 meters per second squared. To find the force, you would simply just have to multiply those two numbers, which would equal to 2,800. That is how you use Newton's second law. You know how to use this law, but you still might be wondering, what is F is equal to m times a? Well, force is directly proportional to mass and acceleration. Just imagine a ball of a certain mass moving at a certain acceleration. This ball has a certain force. Now imagine we make the ball twice as big, double the mass, but keep the acceleration constant. F is equal to ma so that this new ball has twice the force of the old ball. Now imagine the original ball moving at twice the original acceleration. F is equal to ma says that the ball will again have twice the force of the ball at the original acceleration. Here is more about what we just stated, but in more simple terms. If you double the mass, you double the force. If you double the acceleration, you still double the force. But what if you double the mass and the acceleration? That would be 2m times 2a is equal to 4f. Doubling the mass and the acceleration quadruples the force. So, what if you decrease the mass by half? How much force would the object have now? That would just mean the force is equal to 2 newtons. What does F is equal to m times a say? F is equal to m times a basically means that the force of an object comes from its mass and its acceleration. Something very massive, which has a high mass, that's changing speed very slowly, low acceleration, like a glacier could still have great force. Something very small, low mass, that's changing speed very quickly, with high acceleration, like a bullet can still have a great force. Something very small, changing speed very slowly, will have a very weak force. Newton's second law proves that different masses accelerate to the Earth at the same rate but with different forces. We know that objects with different masses accelerate to the ground at the same rate. However, because of the second law, we know that they don't hit the ground with the same force. Here on the picture listed to the side, you can see that a potato is falling. The potato is going at a force of 98 newtons and has a mass of 10 kilograms. To find the acceleration, you would simply just divide 98 over 10 to get 9.8 as your final answer. On the object next to the potato, you would do the same thing. Divide the force by the mass to get your acceleration. Newton's third law states that force acts in equal but opposite pairs. For every action, there is an equal but opposite reaction. When one object exerts a force on another object, the second object exerts the same size force on the first object. Example: when you push on a wall, the wall pushes back on you with a force equal to strength to the force you exerted. Forces always come in pairs. You push on the wall pushes back. Newton's third law. Whenever two objects interact with each other, they exert force upon each other. Sit on a chair right now. You will see that your body exerts a downward force on the chair, and the chair exerts an upward force on your body. Two forces resulting from this interaction, a force on the chair and a force on your body. Two forces are called action and reaction forces. In Newton's third law, how is weight measured? As you stand on the bathroom, scale your weight pushes down on the scale. This causes the scale pointer to show your weight. Newton's third law tells you that the scale pushes back on you with a force equal to your weight. This force balances the downward pull of gravity on you. Your weight pushes down the scale as the scale pushes back to you. Here's an example of Newton's third law. How does a bird rely on Newton's third law to fly? Well, when a bird flies, its wings push in a downward and backward direction. This pushes air downward and backwards. By Newton's third law, the air pushes back on the bird in the opposite direction, upward and forward. This force keeps the bird in flight and propels it forward. Conclusion. Newton's laws of motion. First law. An object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon an unbalanced force. Second law. Force equals mass times acceleration. Third law. For every action, there is an equal and opposite reaction. Thank you for watching.